idea for numbers 1 through 4. This is pretty calc. You guys can ignore it. Sorry. Come back. A big idea for numbers 1 through 4. If we can get pairs, if we can get something squared under a radical, what are we allowed to do? We're allowed to cross it out and just say it's A alone. Okay, that's the idea of numbers 1 through 4. We're looking for pairs. We're looking for items that are square. Jordan, go ahead.
For like a couple of them, like for one of them, I accidentally put minus instead of plus, and one of them I put actually put plus or minus. So like, do I even need to like write that down because I know like it's just like I just forgot.
Still write it down because when the TA is grade, they take off points for any points missed that you didn't correct. But it should be a quick correction.
For missed problems, so I just say like I forgot to put
Just mess up the sign.
Yeah, that's how most of my problems.
Yeah. All right, number 1. Here we go. So, kiddos, number 125. Is he something square? No. Okay, well, what goes into 125? Can you guys tell that 5 goes into 125? Yeah. Okay. So I can go ahead and split up 125 to be 5 times. Did anybody figure that out on my test? It's 5 times 25, right?
Yeah.
Okay. If you divide your calculator 125 by 5, okay, you have a correction on this one, right? Let's go. And then I can go ahead and why am I going to split m to the 7th up to m squared and m squared and m squared and one more m? Why am I doing that?
Pairs.
Get them in pairs. So how many pairs is in 7? Well, 3. 2 and 2 and 2 makes 6, and there's one more. Okay? Now, I can go ahead and take square roots of 5. Take a square root of 25. Hey, isn't 25 a nice square root? Because 5 squared is 25. Good. I'm going to have a square root of m squared, square root of m squared, square root of m squared, and a square root of m. Now, basically at the end of the day, I'm going to put the answer way up here. Something's going to, at least one thing's going to be stuck under the house, under the radical, but some things get to also come out of the radical. So question, can you guys tell first of all, who's still going to be stuck under the radical? Yep. M is going to be stuck under, and 5 is going to be stuck under. So I'm going to say 5 and m are not pairs. They're not squares. I can't cancel out the radical. But what can I do with each of these m squares?
I cross them all out.
And I have just an m and an m and an m, no radical.
Yeah.
So m to the power of what? 3 gets to come out. Do you see it? Now it's not a cube root. It's m cubed. I'll make it a little bit separate. But what have I not yet dealt with? I've dealt with everything but. How did I take the square root of 25? Yeah. It's the square root of 5 squared. And so either you have memorized square root of 25 is 5, like square root of 4 is 2, square root of 9 is 3. If you don't have it memorized, you could have seen that 5 squared is 25, so then we also have a 5 on the outside. Done, Dylan, done. We're done. Okay? If anybody hears music coming out of someone's headphones, just measure real quick and be like, hey, turn it down a little bit. Okay, number 2.
Wait, what?
Any questions on number 1? Does it make sense? Alan?
Alright, so like you factor all them down, right?
Yeah.
And
Yeah,
then
yeah. Break them down, look
kind
for
of
pairs.
lost on what you do after that.
Okay. Do you see how m to the 7, there were 3 pairs and then 1 single?
Yeah.
Okay. So I was able to cancel out the radicals for each of the pairs.
Okay.
The radicals are gone, so it was just, if you want to think about it this way, it was square root of 5 times 5 times m, 1, 2, 3. If this helps, that's what would have been the next step. And then I grouped together everybody without the radical and they went in front. And I grouped together everybody with the radical and they went underneath. Does that make a little more sense?
Yeah.
Okay. So there is an in-between step if it helps. So make sure you get it. Okay, so no other questions on number 1? All right, number 2. What was the problem? I had a problem. I'm not allowed to have a square root on the bottom. If I just have a square root alone, how do I get rid of that square root on the bottom? Good, multiply top and bottom by the denominator. So now we're at number 2. Now, fractions we multiply across, right? So on top we get 4 root x, and on bottom, how do I do a radical times a radical?
It's 6 squared.
Yeah, I can put the 6's together. 6 times 6 or 6 squared. And Tyler's right. If I have a squared, what can I do with the radical and the squared?
What's it is?
Yeah, cross them out. So what's left in the bottom? A 6 alone, right? So I have a 4 and a root 6 on top, a 6 alone on the bottom. Can I reduce? Yes, but careful. That 6 is under a radical and that 6 is not. I can't put those together. One's in the house and one's out. Right? But what can I do with the 4 and the 6? Yeah, I can reduce. What goes into 4 and 6?
2.
How many times is 2 go to 4? And how many times is 2 go to 6?
There it is.
Now, I don't think I took off points if you got 4 root 6 over 6, but the best answer would have been 2 root 6 all over 3. So the key on number 1 was break it down, look for pairs. The key on number 2 had to multiply top and bottom by the radical. It's called rationalizing. All right, Johnny, get your music and then you gotta be correct. It's okay, you just sort of focus on the part, but it's okay, number 3. Sorry, any questions on number 2? We always do that whenever we have an alone radical in the bottom. Always multiply top and bottom by the radical. What would the topic be, or the concept, the misconcept for these ones? Simplifying stuff with radicals, yeah. I'd say simplify the expression or simplifying radicals. That's the misconcept, you guys. Don't forget to write in misconcept, simplifying radicals. Okay, number 3, there's also a radical in the denominator. Question on 2? Question on 3? Let's see how it's done.
Oh, yeah.
3 was hard because you couldn't just multiply by square root of 3. Can I zoom in on 3? Is that okay, you guys all ready? Anyone remember the special word for multiplying by the exact same thing but with
Foil.
the opposite sign?
No.
We're going to foil. We're going to. But what's the name for this snazzy guy where it's the exact same, but since there are 2 pieces, I have to keep it the same but with a minus? Starts with a C. Conjugate. Conjugate. I'm going to put parentheses. Whenever you have a square root with somebody else, you always have to multiply top and bottom by the conjugate. Okay. So, fractions, multiply the top, multiply the bottom. On top, since I just have a 1, can't I just distribute him?
Yes.
Okay. So 1 times root 3. Minus, what's 1 times 2? That stays the same. 1 times root 3 is root 3, 1 times 2 is 2. On bottom, oh guys, this is a very important algebra thing. It just showed up in a different way. Dylan, here we go, bud. Do you need number 3? On bottom, maybe, okay. On bottom, Angel, you said it, so I just need you to say it again. On top, we just got to distribute the 1. On bottom, what do we have to do when we have 2 binomials and we're multiplying them? Do you guys remember what Angel said? It was good. Foil. Thanks for that. So when I foil, I need to do first, root 3 times root 3, I'm just going slow, is going to be root 3 squared, or root 9, whichever way your brain likes it better. Outer, it's going to be 2 times root 3. One's outside the house, one's inside the house, so I have to keep them separate, but there's a minus. Inner, I have a 2 and a root 3. One's outside, one's inside. I have to keep it that way, but there's a plus now because it's a positive times a positive. You guys see the smiley face coming? There it is. It's right there, right? Remember our foil? Remember our little guy? He has a little nose. He has a little smile. Okay? It's just foiling. It's just foiling. When I multiply last, positive 2 times negative 2 is a negative 4. Okay. Now, this is a little daunting to a lot of us, but
Very daunting.
I know, it's okay, there's a lot going on. But can who, it's okay, who can tell me something that I can do to simplify, because I'm not done yet. Alright.
The 2 squared 3.
Yeah, Caleb, do you see on the bottom?
So it'd be
The positive 2 root 3 and the negative 2 root 3 cancel, they're gone.
Yeah, it'll be root 3 squared.
Oh, can we do something with the root 3 squared though?
yeah, you can change that.
Cancel.
So it'd be 3 minus 4.
The squared and the radical cancel, it's just a 3. So I'm gonna end up with root 3 on top, minus 2, 2's not under the house,
3 minus 4.
and 3 minus 4. Wait, I can do 3 minus 4, can't I? So root 3 minus 2, 3 minus 4 is negative 1. Now guys, that's a good answer, and I took it if people wrote that. But since it's just a negative 1, I can also go ahead and bring the negative sign up to both of the numerators and get negative root 3. The sign of the first one flips, and the sign of the second one flips. Both of these answers are right. I should say probably either of those answers are right. Both of them are right, either are right. Now, it's kind of getting in the way of my other problems, so I'm going to put this guy up here. I'm going to write a little or right in here, just to make room. But both of those answers are basically just as correct. Now guys, in number 4, if you need it, here we go. In number 4, if you need it, let's check it out. In number 1, didn't we have to break down what's underneath to simplify? Okay, that's what you need to do in number 4. But you're going to do one piece, break down the 20. The other piece, break down the 45. Let me give you just a second. What numbers go into 20 that you can break it down into? And what numbers go into 45 that you can break it down into?
20, right?
Oh, I love it back here. You're actually looking at stuff. I'm not sure. I'll get there. Okay. Try to give you guys freedom, but it's only for being productive. Here we go. Number 4. So you guys were starting to give me some ideas. What goes into 20? 5 goes in, and what else? 4 goes in. Why am I going to leave x squared just the way it is?
Because
See it there?
you have this x times x is still
You can't do anything, right? But x squared, can I do something? And the answer is yes. Now I get to the next piece, 5x. How can you break down 45? What do you guys think of?
9 and
9.
5 and 9. Sure, we'll take it.
how did I get that wrong?
It happens, it happens. There's like little things. Was it a half or a whole?
Wait, no, it's like
Oh. So now when I go ahead and split up, I'm going to split up 2 root 5 times root 4 times root x squared minus 5x root 5 and root 9. Does anybody see any of these square roots that we can actually do?
9.
Yeah, what is square root of 9, guys?
3.
Good. So we can say times 3, no root. If you guys want to think about it as 3 squared and the squared and the root cancel, 3's left. That works also. On this side, 2 is 2. Root 5, we don't know that. How about root 4? Is that something good? What's the square root of 4?
2.
2. What can I do with the square root of x squared?
Cancel.
Good. And what's left?
X.
Good. Just x. There's the minus in between. So let's take it one piece at a time. What can I do with this side? Who all gets to combine?
All the ones that are under or
Yeah, so we have a 5 that's under, but how am I going to put the 2 and the 2 and the x together?
sorry before.
Good. 2 times 2 is 4, and the x is with them on the outside.
Wait, why is it flexing?
2 times 2 is 4.
Where'd you get the 2 times 2 from?
Because there's one there and one there.
Hey.
See? They're both outside the house, so we can multiply them. Is that okay? What can I do with the next term? 5 underneath the house, but who gets to be in front?
I think 3.
And 3 times 5, because aren't they both outside?
15.
15. Now here's the crazy thing. This is all right. But as you look at this, guys, are these like terms? Do they both have a square root of 5?
Yes.
Since they're like terms, I can actually say what is 4x minus 15x, or if you want to see it,
11
we can pull the root 5 out. It's called that factoring. And we can say, hey, we can put these guys together. It is 11, but is it positive or negative?
Negative 11.
So we're going to have negative 11x, and the root 5 gets to remain. That's the best
So you
answer
don't,
for
you don't combine both of the root 5? Like you wouldn't multiply them?
No, because it's a like term. See how it just kind of stays on its own?
Mm-hmm.
These ones can combine, but the root 5 just remains. Jordan?
You put 15.5 out of 20, and like I look at the markings, and it's 2.5 on one side and 3 on the other, so I missed 5.5. But you said plus 1. You never added the bonus, so it should have been 4.5. So then I would have gotten like a.
You can give it to me. All right, guys. So for number 5 and 6, we're going to switch sections. All right, 5 and 6 get us the directions. It's all about the directions. So let's change the misconcept. For 1 through 4, it was simplifying radicals. For 5 and 6, it's using a graph to solve. Using a graph. This is due tomorrow, kiddos. If you're not doing it with me, it's kind of silly.
Is it really doing that?
Yeah, but that's what we're doing. On 5 and 6, it was super easy if you only knew what the question was asking, and some of you didn't.
I got
5 and 6, to solve the equation, we're looking for when the graphs equal 0. Do you guys remember what the zeros are?
Yep.
They're the
Crossing the X.
x-intercepts, where they hit the x-axis. So my ones that got it right, what did you see about number 5? Where does the x cross, or where does the graph cross the axis?
-1, 0, 1.
Ooh, not negative 1.
-4.
Yeah, there's -1, -2, -3, -4. So at -4.
Number 6.
Oh, got it. And then where's it hit on the positive side? Caleb, you have this one wrong. Where's it hit on the positive side?
1.
1. So it hits at 1 and it hits at -4. Now where does it hit for number 6? Those of you guys that got it right.
1. Why no 1?
-1, positive 1,
Wrong.
and 0. There's 1 at -1, 0, and positive 1. All right, next section. Sometimes it's all about reading the directions, but guys, if you look at your chapter reviews, the directions are the exact same as the test.
No, I can do it for number 5. I like how I added an extra 4 because I thought
Like
I
when you
saw.
were counting over.
Yeah,
Some people put the Y's, they messed up in that
yeah.
one.
That's why I put the positive 4
Yeah.
for y when it's supposed to be an x.
Yeah, just the X. And some people just didn't know what the directions were asking for. That's what the corrections are for. Now, kiddos, on number 7 and 8, it's all about solving with square roots, if you want to shorten the directions. 7 and 8 are all about solving with square roots. But who are we solving for? What are we trying to get alone in both of them? Good. So let's figure out where that X is, and let's say, hey, we need to get to him. We need to get to him. Kiddos, in number 7, what do you take apart? What do you take to the other side?
-6.
Good. Get rid of that 6 first. Yeah.
How, if I missed the point on number 5, how would I put that as a correction?
You can just show the answer, and if you want, you can say something like x-intercepts, like if you want to describe it. That way your brain's kind of like, that's right. The graph, zeros, look at where it hits that.
Okay, thank you.
Good job, Ben.
Are you filming this right now?
Yeah.
Alright.
Yeah, I'm taking it. It'll be like where the normal video is. Okay, so for number 7, I'm moving the 6. 14 minus 6 is 8, everybody, right?
Yes.
Okay, I still have to get to my x, so what needs to go away next? The 2. Divide both sides by 2, and I get x squared equals what? 8 divided by 2? 4. Hold up real quick, let me see what you think. Just go ahead and skip down, count to see how many you've done now. Skip down to, like, see if you miss number 7 or 8, just skip down, like, how many spaces you need, okay? You can teach that problem. So I'm literally doing the work for you right now. How do we get x alone if there's a squared, guys?
Square rooted.
Yeah. And if you get x alone, there is a squared, let's put in a square root. What I do to one side? Exactly. Now, some of you missed half a point on this one because you forgot when you put a square root, over the 4, it needs to be a plus or minus. It's so easy to forget, right? It's a struggle. So easy to
It
forget.
just slipped my mind.
Yeah.
Actually, no, it didn't. I think
So when you put a square root in, you gotta put a plus or minus. It's kind of hard to see, that's why I'm putting it in the answer down below. You gotta put a plus or minus. The nice thing is that that square root does allow you to cancel out the squared and the root, and just the x remains. But the plus or minus was where a lot of people missed a little bit of points.
no, it's just like first time I forgot to put the 2 over the square root, so then I just kept.
Oh, you did square
and I
root
divided
first.
2 over 8 to both sides with the 2 different equations. And
Yeah, divide the 2 first, divide the 2 first. Okay, as we go to the next one, it's a little bit harder. But if you guys look at it, do I need to add the 1 first, square root first, or move the 3 first?
Subtract the 3 first.
Good. Subtract the 3 first. It's half points, probably. Oh, it's the point. So I get x minus 1 quantity squared, p's alone, because I've gotten rid of the plus 3. And what's on the other side, guys?
9.
Good. Now, we see the x, he's still there, but we have a minus 1, the even bigger problem is what's around it. There's a square, yeah.
So,
How do you get rid of the square?
square root.
Because the directions are supposed to kind of help you, right? You need a square root. What you do to one side, do to the,
Other.
and what's the mistake a lot of people make?
Plus or minus.
Plus or minus. So the squared and the square root cancel, just like the squared and the square root canceled over here. So what's left on the left? X minus 1. Good. X minus 1 is left on the left. What's left on the right? What is the square root of 9? Do I know that right?
3.
Plus or minus 3. Now, Angel said a second ago about the 2 equations. Does this problem need 2 equations to solve?
Yes.
Yeah. So you can go ahead and go from this to x minus 1 can either, do you guys remember this? Either equal
Yes. 3.
positive 3 or x minus 1 equals,
Negative 3.
yeah. So we just have 2 little equations to solve.
Negative 10.
And some people are already going ahead and solving by adding 1 to the other side. X does equal 4 or, what was the other one that you guys got?
Negative 2.
Negative 2. X equals negative 2.
British.
Well, that's pretty bad, but. Okay, so, there's x equals 4 and x equals negative 2.
I have a question on the bear.
Let's wait. I can't go over the whole thing again. But, did you multiply by the conjugate first?
I have no idea. Wait.
Take your phone, Johnny, you want to take a picture of it? So you can look at it.
No, it's okay.
Okay. It'll be in the video tonight, so you can come back to that. Alright guys, numbers 9 and 10. Ugh, completing a square. Now some of you actually like this. I saw you try to do it like
I
10
didn't even
times.
try.
That's pretty good.
Very
And some people just skipped.
Hard.
Now, I said, sometimes the hardest part, Joe, you still hanging with us?
Yeah, I took down already.
Okay, okay. I remember I said that before you even can complete the square, you have to remind yourself something's missing. You guys put a blank on your test?
I did.
Good. Some people did put blanks and they knew they could fill them in. Some people forgot that stuff.
2 question marks.
Before you can complete, it's okay, here we go. Before you can complete, you have to remember something's missing. So you gotta put a plus blank. Yeah. And on number 10, I'm gonna do the same thing and say, hey, I'm missing somebody, right? And I actually didn't even give you a crazy one with a number in front. Now, you had to remember, this was one of those memorizing things. You had to remember how to find a special number. Does anybody have, did you write in your test anyone? What was the special way of solving for that?
Multiply by 1/2 squared.
1/2. The middle number squared. So what's the middle number on number 9? Yeah, I'm gonna put 6 in that little formula. And for number 10, what am I gonna put in this little formula? Good. Negative 4 times. Put in a 6 and put in a negative 4. So 1/2 of 6, cut 6 in half and you get 3. And 3 squared is 9. So I'm gonna go ahead and put in 9. Now, I kind of backtrack. The blanks are empty, I need to fill them. I take the 9 and I put in, and what I put in on one side, I can also put in on the other side. You see how I'm filling the blanks? So then, when we fill the blanks, and here's the jump that a few of you guys, if you got that far, you might have gotten messed up right here. Because next we had to factor. The whole point is that we've made a perfect square.
I thought like once you found out the thing that was it. So.
Here's how you keep going then, okay? 7 plus 9 is 16. And to factor this guy, we can always make him, if we complete the square, we can always make him the perfect square of the square root of the first, the square root of the last, with whatever sign is in the middle. It technically ends up being the same as this guy. Does that make sense? So the square root of x squared is just x. The square root of 9 is 3. And I put a positive because I have a positive sign in the middle. It's also the same thing as using this middle number right here, which is the 3. Now we're going to solve that in just a second. We have it all primed and ready to go. But let's go ahead and see if we can get number 10 up to snuff also. For number 10, what's our special number, kiddos? Who needs to be squared? 4 cut in half, though. Negative 4 cut in half is negative 2. And negative 2 squared is 4. Does that make sense? Take the 4. He's our special number that we fill in. Okay? So on the right-hand side, we just have 10 plus 4, which is 14. Now, a few of you guys accidentally made him a negative. But negative 2 times negative 2 is a positive 4. Now, here's the tricky step again. We have to factor this guy. So to factor him, we know he's a perfect square if we've done it right. So we can already make it squared. It's going to be an x, good. It's going to be a minus, good. 2, got it. Which is the same thing as this little guy in the parentheses. Or you can think, take the square root of him with a minus. Now guys, hold on. Don't these problems look kind of like number 8 up here? Because now, what are we going to do to both sides? The same thing we did up there, we're going to square root. And we're going to do plus or minus square root, right?
When I messed up, I forgot.
It's so easy to forget, yeah? That's why I practice like every night, a little bit of homework every night. That's why I do it, because it's so easy to forget. We got to train our brains. So I'm going to throw in square roots, but don't forget, what's a little mistake a lot of people make?
That's where I stopped. Stop there and put that as the answer.
But now it makes sense, yeah? Let's just keep going and solve. So we can cross out, Same thing here, plus or minus. Now, which of these square roots do we like taking? The one on the left or the one? 16 we like, because what is the square root of 16?
14.
Good. Plus or minus 4. Over here we have x plus 3. Now guys, are you going to make 2 equations and solve for x?
Yes.
Good. The problem over here was square root of 14. Did anybody do that as a decimal?
3.741.
3.7.
So I'll do 3.7, just to make it easy.
I just did the round.
Oh, okay.
That's what I was gonna ask.
That's totally fine. I'll take that too, Jen. two equations with the decimal and solve? Yes. But isn't that what we did once again up in number 8? Does that make sense?
Mm-hmm.
So I'm gonna see if you guys can finish off number 9 and 10, because I want to at least get to the back page before class is over, okay? Did I or TA write the right answers down for you guys to see?
No.
Yes.
Yeah.
Oh.
It should be in like a color pen.
Kind of.
So on 9 and 10, hopefully you can kind of see the right answers. If not, I'll have them, obviously tomorrow if you want to check the right
9
answers.
and 10. All the other ones, yeah.
But do you know how to finish 9 and 10 now?
Kind of. Actually, I do, for sure.
Kiddos, I think out of the back,
Oh.
numbers 11 and 12 were some of the most commonly missed on the back.
Can I get another word?
11 and 12. If you guys are looking for a missed concept on 11 and 12, I would say discriminant. I would just say discriminant, because that's where you got messed up. A few of you guys forgot about the formula, but some of you were able to write it down. What is the discriminant? What's the formula for it? Do you remember?
Is it
Well, you need to get.
B
Oh.
to the
B
second?
minus
Four
B
AC.
squared minus 4 AC.
Yeah, good help. Good job. B squared minus 4AC. And we have, if that number ends up, no, a lot of you guys messed up on your negatives and positives. If you messed up on 11 and 12, but you knew the formula, I bet it was negatives and positives. Remember for quadratics how we can know what A is, and B is, and C is? What's A for number 11, Angel?
A for number 11. Negative. Or the or.
Like in the actual expression. Which number is A? 2, negative 1, or 2?
2. It's 2 negative.
And then B is
Then B is no negative 1.
the number in front of X.
Yeah,
Good. And then C is.
3.
So when I go to plug in, we need, now guys, here's where a lot of you messed up right here.
So like a lot.
B is squared, all of B. So negative 1 is squared. Some of you forgot the parentheses and it messed you all up. B is squared, negative 1 is squared. Then we plug in who is A and who is C. We use the same format for both of them. Only problem on number 12 is something that's kind of hidden. So we plug in B, and then we plug in A, and then we plug in C. Then the name of the game is simplify. Tyler and Jordan, pay attention. So, what's negative 1 times negative 1? Positive 1. That's where a lot of you guys made a mistake. Minus, and now the name of the game is multiply. 4 times 2? 8. And 8 times 3? So if you do 1 minus 24, the discriminant, I'll write it over here to the side, the discriminant should have been negative 23. Ooh, a negative discriminant, do you remember what happens if we have a negative under a square root?
0.
No
That's
solution.
no solution.
That's what I messed up on.
Negatives aren't allowed. For number 12, and I'll let you guys finish him, but I am going to help a little bit because some of you didn't realize that you couldn't steal A, B, and C right away. They weren't written the right way. X squared was there. 14 was there. Yeah, 7x was on the wrong side. You had to subtract 7x. Then you can say A is 1, B is negative 7, and C is 14.
Yeah.
14. At this point, kiddos, I know, hold on. Let me finish this right here. At this point, you need to plug into your formula. If it's a 0, then there's one solution. If it's a positive number, then there are two. And if it's a negative number, okay. What can we get to?
We didn't get to
The end. Okay? By tomorrow, if you can finish all the way through 17, and even the bonus if you want, do so. But you need to have done up through number 12 for sure. Does that make sense?
Yes.
Up to number 12 for sure. Try to keep going. Open up your notes. Get into your book. Let me help real fast. These ones are from section 9.1. Here, I'll do this one. This one is from the last section. Justin, I haven't said this again. And this is from the second to the last section. Okay, look in your notes at the last section, second to the last section. Are you tracking? Alright, okay, we'll see you tomorrow. Work on these corrections. Work on chapter 9.